What's question 20 all about? Calculate NPV or PDUR05. Calculate and comment what percentage fall in selling price would need to occur before NPV fall to 0. That's sensitivity analysis. Are you clear now? Got it? That's doing sensitivity analysis. Sensitivity analysis is quite easy. Just turn your NPV into a mathematical formula. Turn your NPV into a mathematical formula. Put everything like what multiply what plus what multiply what just plus. Just make it into a single formula. And then if they ask you to 0 means just put your NPV 0 and put your selling price as S. Okay, repeat again. Your NPV calculation is just a mathematical formula. Just remember that. NPV is a mathematical formula whereby cash flow times discount factor equals PV. You add up all the PV, you get your NPV, correct? Cash flow is a mathematical formula. It's basically cash in minus cash out. Got it? Selling price is a component of cash in. Cash in times selling volume equals cash. The selling price times the volume of sales equals to cash in. So think about it mathematically. Just move from table, formatted table, move into mathematical basis. Once you move it into a mathematical basis, it can solve very fast. So always think mathematically sometimes. In this paper, you need to switch from formatted answers, table, that's presenting to board of director, that you present in table. But when you want to solve it from sensitivity point of view, convert to mathematics. Okay, do you understand the concept of converting to mathematics? Yes, no? The whole thing is a formula only. Plus, 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 plus equals what? Okay? Right, so that's the meaning of that one. Anyway, 6 marks. It's not supposed to be so complex. Try it out and see. Explain the strength and weakness of NPV as a basis of making decision making in a capital rationing situation. Okay, this is capital rationing situation. Formulate an appropriate capital rationing model based on the above investment limits that maximizes NPV for the department rule. Finding a solution for the model is not required. So you just have to formulate an appropriate capital rationing model. Now, then assume the following outputs is produced by capital rationing model. This is the output. Explain the figures produced in each of the 3 output categories. Provide a brief response to MD opinion by explaining why Arbore may want to impose capital rationing on his department. Explain the features of capital investment monitoring system. Discuss the benefits of maintaining such a system. This is a bit theoretical questions. Okay, now follow? Okay, now have a go on the question. See whether you can figure out what you have to calculate. Try it out. It's not such a huge question. Do you know what to do? It's a simple NPV calculation. First part is just calculate NPV only. 6 marks is supposed to be very easy to get, the first 6 marks. NPV calculation. NPV calculation for part A. Okay, I think I better go through this question with you. Actually, the question is not that heavy. Arbore is a large listed company with many autonomous departments operating as investment center. It sets investment limits for each department based on 3-year cycle. Projects are selected by department who have to fall within investment limit set for each of the 3 years. All departments will be required to maintain a capital investment monitoring system. Okay, that's the one that the examiners already asked you how to do. Okay, and report on their findings annually to some. Capital investment monitoring system is kind of like a benefit analysis that you study in P3. You know, benefits management system. That means, do they deliver the benefits that you're supposed to deliver? Okay. The Arbore department is considering following 5 investment projects within the 3 year of the initial investment expenditure, followed by several years of positive cash flow. Department's initial investment expenditure here you got limits. 9 limits are 9, 6, and 5. So these are your limits for capital rationing. Make a note. These are critical numbers. So those are critical numbers that you need to pick up. Got it? Okay. None of the projects can be deferred, and all projects can be scaled down but not scaled up. So can scale down, cannot scale up. Okay. PDUR5. That means here you can see that there's something missing here. Got it? PDUR project annual operating cash flow commence on end of year 4 and lasts for a period of 15 years. Now, careful, this one is for 15 years, which kind of means you're going to use a cash flow annuity kind of thing. Okay, it's end of year 4. Remember, it's commences at the end of year 4 and lasts for 15 years. Does that make sense? So you need to figure out your cash flow pattern. So it's year 1, 2, 3, then year 4 onwards until year 15. Correct? So how? Also can, no problem. Okay, so basically there is a technique. You can do the annuity of 15 minus the annuity of the first 3 years. Yes or no? You would have got the number. Did you try that number out? You must get that number out. I told you it's mathematics. You have to be mathematically inclined for this paper. Got it? So next one, the project generates an annual sales of 300,000 units per set at a selling price of $14. So they've given you certain information here already. Okay, and incurs a total annual relevant cost of 3230. Although the costs and the units sold of the project can be predicted with fair degree of certainty, there's considerable uncertainty about unit selling price. Okay, the department uses a rate of return of 11%. Inflation can be ignored. Durval's MD is on the opinion that all projects with return a positive NPV should be accepted and does not understand the reason why Arbore imposes capital rationing on department. Furthermore, she is not sure why maintaining capital investments would be beneficial. Okay, now, have you calculated the NPV? So we're doing this question, and when you're doing this question, so let's go to this question. This question is called Arbore. Okay. This question focuses on one issue. Okay, let's look at this issue here. First part, you need to figure out the NPV, yes or no. Okay, and you're already given just the investment, but they already told you the cost and this one. So what is the revenue? Revenue is going to be $14 times 300,000. Are you clear that one? Okay. Annual cost is going to be, how much is this? 323,000. So annual cash flow is going to be Are you okay this part? Right. So the NPV, which should have been straightforward for you, should have been 2.5. You'd have got, how much is it? 2.5 times 1 plus minus 1.2 times how much? At 11% it was 0. 11% was 8. Second year was? Not first year, this one. No. So it's supposed to be 9, 0.
Means the project is 1 to 14 years.
Yeah. No. There's year 2, year 3, correct? Okay, wait. I see whether you did it this way now. Okay, plus. Then the other one is minus. So let me put everything in bracket first. Is minus 1.4 times 0.812, okay, plus 0.97 times 15 years is 7.191 times 0.731. Okay, that's the answer. In 15 years now, not 150. Did the question work? It's 15 years after that, right? Yeah, year 4. After year 4 for how long? And last for? Understand now? It lasts for 15 years now. So the cash flow is 15 years now. The annuity factor must be for 15 years. Read the sentence properly. But year 4 lah. So year 4 discount value is you put the 15-year annuity, you get the year 4 value, your year 4 value you discount it back again. Are we okay? Can? Can I cannot? Can I? Yes, no? Cannot. No, check, you must know, you must think first. The 0.97 you know where to get, right? This 0.97 come from here. Lah. This was the cash flow from here, from the question. 1, 2, 3. Are you okay? Yeah. This one is the one that you need to know. It's 15 years. This one you have to adjust back to current year. Okay. Are we okay now? Can. Okay. So now NPV got ready, right? So your NPV is 381,000. Correct? Okay. Sensitivity analysis now. Let's do sensitivity analysis. Now, sensitivity analysis, you just have to figure out one thing. Okay? Let's figure out one thing. Let's do it mathematically. These numbers are all fixed already, right? Whatever is fixed, lock it down first. Can you figure out how much is this worth? So it's going to be this front three numbers are what? Add up all this. Minus 4, 1, 2, 3. 4, 7, 1, 8 lah. Okay. Plus, now this is how it goes. You see the number up here? Let X become your S. So it becomes, this is the formula part. S times 32300. Are you clear? That's your cash flow, isn't it? That's how you got that 0.97 times point times 7.191 times 0.731 equals 0. That's what I mean by mathematically convert everything. Can you get S? Because this number, this number is the one that you need to be looking at. Are you clear now? This number comes from here, correct? And you were asked to figure out this number as an issue. Can you understand now? This number is the one that's now adjusting, correct? So if this number is adjusting, so you know this number is adjusting, so this is how you work it out back again. How much is this? This one is not minus, this is going to be 4718000. Okay. Better put it like that because everything need to be in the same format. What do you get? Yep. So therefore, sensitivity wise is 14 minus 13.76 divided by 14 times 100% equals to 1.0 answer one person. Are we okay this part? Got it? Here. Are you okay? Okay? Make sure if this question is not come out, you better bang it first, you know.
Yeah.
It's not hard. It's not hard, but you can easily get something for, especially sensitivity analysis is actually quite easy actually. You know what you're doing. Follow?
But if MPV use table form,
Can, no problem. It's not a problem. No, but if it's table form, it's table form. It's for presentation. Table form is for presentation. You just need to be flexible a bit in your thinking of the paper. The table is for presenting to directors, board meeting. Then you present in table and then highlight. But when you are doing sensitivity analysis, you need to quickly start thinking of it in. This is no problem. The mark, they will give full mark for this. No problem. You don't need to do a table for this. Because the question only asks you to calculate NPV. It doesn't say prepare a statement for me.
because we want to pick up the figure from table, we need to stop it. I mean,
You need to organize it lah. So here you notice properly, I've already put it in as all the negative values and all the positive values. You just have to figure it out as plus year by year. If you are going to do duration, all that, then you need the table. That's why I remember earlier on you see me, I switched to a table here. I was going to do it under this one over here. You can see now. When I did here, I thought of doing it mathematically, but then you needed the table already because you were supposed to do project duration. Once you need project duration, you must do table already. So you need to know what your question is asking and you need to be flexible about it. Don't go and approach it stereotype. Stereotype means like every time table. Then you use every time table. That question didn't require you to table, you're wasting your time. The question only requires you to do a mathematical calculation. So do the mathematical calculation. Got it? Flex a bit, huh? So are we okay with this one now? 6 marks. Can, huh? Okay. Next, you got well, you better give a conclusion. What do you think? Calculate. Oh, you calculate, right? Oh, comment. Let me give you a comment. I think I already gave the comment. So this is a comment. Does that make sense? Done lah. That's the comment part of it. Clear now? Okay. Let's do the next part. Part B. Well, NPV. Strengths and weaknesses of NPV. This is quite straightforward, common sense question, isn't it? This is multi-period rationing. Requires multi-period rationing requires linear programming, and you got some variables that you can use. Okay, are we okay this one? The objective function is going to be maximize two four four x2 352 x3 320 x4 plus the last one was ours was how much? Ours was 3 8 1. Are we clear as well? Got it? Okay, that's your objective function. Maximize this. Next, constraint functions. Year 1, I don't know how to enter that symbol. You know that symbol, right? I can't put that symbol. You have to put that symbol yourself. Got it? How much? 9,000. Year 2. Do you understand what's happening now? Yes, no? Year 3. That's your constraint function. X1, X3, X4, 5, This one is going to be 1100x1 plus 2800 x2 plus 3562 x3. You don't need to put 0x4, isn't it? Clear? Got it? Plus, but you want to just put it in x4 plus 1200x5 6000. Got it? And the last one is what? 2400 x1 plus 3200 x2 plus 0x3 2200 4 this one is. Are we clear on this one? Yes, no? That's 3 marks. Right? Okay. Press it. Only to do to solve. Assuming following output. Total final value is 11849. Adjusted final value is given there. Constraints utilized year 1 0, year 2 0, year 3 0. Fully utilized. Okay. Explain the figure for each of the 3 categories. That's all. So what is category 1, category 2, category 3? This is part C. So category 1 is what? This is the NPV earned. Are you clear? NPV earned from the 5 projects. Given the constraints. Got it? Two. Of each project undertaken, given that projects can be Done. That's the meaning of that. So you didn't need to panic. You just have to interpret what it meant. Got it? Next one, I ask you to explain why Arbore might impose capital rationing on this department. This is part D1. Okay, done. Two, what is a CIMS? So what's the benefit of a CIMS? Okay, done. That should be enough. I've broken the question to what is the characteristics and what is the benefits. Does that make sense?
Can stop
Okay, for lunch. Weird. Can recall nothing. That's the responsibility. Okay. Any questions there? This chapter is not come out yet. This area, high chance this chapter will be coming out this semester. This zone lah we're doing right now. Got it? Market there should be one full-blown question in this area. APV lah, especially one more called APV. Might get APV, you might get a 25 mark question on a project like this. Got it? Okay, let's stop there for lunch. Be back by about 2:30. About 1:50. Okay, 2:30. Yeah.